Hey everybody, welcome to the Solving Literal Equations notes. A literal equation is just an equation with additional variables in it. And so, like, you're used to solving equations and you'll just get, an answer like x equals 6. But a literal equation has multiple variables in it and you're just solving for one of those variables. So you're still using the same algebraic skills. You're still adding or subtracting numbers to the other side, except numbers, they could be all letters. So you're still adding and subtracting things to the other side, terms, I should say. You could be multiplying or dividing by this letter. So it's the same concept. It's just more letters now, okay? So here I'm going to solve each equation for the specified variable. So in this first example here, I'm going to solve for a. So looking at this, I see that it equals c. So that means it's technically solved for c right now. And so if I'm solving this for a, then that means I need to get rid of this minus b, and I need to get rid of this 2. This c is on the other side of the equal sign, so it's not really affecting the a, so I don't have to worry about moving that c around. So I need to move out this 2 and I need to move out the minus b. Well, the first thing I like to do when solving an equation is to look for something I can add or subtract to the other side. So in this case, I can add that b to the other side. And so I have 2a equals, and I'm going to write b plus c instead of write c plus b. I'm just going to keep things in alphabetical order. You'll typically see other people do it that way too. Now, I won't write c plus b equals bc. C plus b does not equal bc or cb. I'm trying to write cb. That's multiplying. Writing bc, smushing them together, or writing cb, smushing them together, that's multiplying. That's saying b times c. These are adding together, and they can't exactly combine because they're not like terms. They're two completely different letters. So you got to keep them separate. Just keep it as b plus c. It can't simplify beyond that. All right, so let me take that out, and then let's get back to this. I'm solving this for a, so I need to get rid of the 2 by the a. So getting rid of that 2, well, 2a, they're smushed together. They are married together. They're multiplying. So if I'm going to split them up because they're married, then I'm going to divorce them or divide them. So I'm going to divide them by 2. And I'll divide this by 2 and this by 2. And so since b plus c, since they're both being divided by 2, you can rewrite it as one fraction actually. You can write it as b plus c on top in the numerator and just put divided by 2 in the denominator. So if they have the same denominator and you're like adding or subtracting fractions, you can kind of combine them and put everything you need to on the top. If it really confuses you, you can keep it separate. You can write it as b over 2 plus c over 2 and it's still the exact same thing. But this is how I prefer to do it, and this is how a lot of people will show you how to do it as well. But that'll be the final answer for that first example. In the second example, I'm solving for a again, and so I notice it equals 0. I'm going to have to get rid of the plus cd, and then I'm going to have to get rid of the b that's with the a. And then anything on this side of the equal sign, the 0, it's not really going to affect the a. You don't have to move anything over on the right-hand side. You'd only have to move something over on this side is if there were another a. You'd need to get all your a's on one side. But there's nothing over there. So always start by looking for something you can add or subtract. In this case, it'll be the CD. I'll move them together. They're multiplied, they're married together. So you can move them together by, adding or subtracting them to the other side. It won't split them up. You can't just subtract out C or just subtract out D. The only way you can split them up is by, dividing them apart. And you don't need to do that for this problem. So I have AB equals 0 minus CD. Well, you don't have to write 0 minus. You can just write it as a negative CD. And then what does AB mean? That means A times B. So the opposite would be to divide it out. So I'm going to divide out the b. And so then I will have a equal to negative c d, or negative c times d, over b, or you could say divided by b. And that'll be my final answer for that example. For this third example, I'm solving for y, and so I have a bit more going on. I notice that it equals to b. There's no other y's on this side, so that b, I'm not going to have to move that around. I notice I'm minusing a, so that means that's going to be the first thing I get rid of. Always look for something you can add or subtract to the other side first. And then again, I'll keep it in alphabetical order. So I'll write x plus y divided by z. Instead of equaling it to b plus a, I'll write a plus b. It's the same thing, but just in alphabetical order. Now, what does x plus y over z mean? That means divided by z. X plus y divided by z. That's the next thing you need to get rid of. I know I also need to get rid of this x because I'm solving for y, but you cannot add or subtract anything away from that fraction until you get rid of that fraction, okay? So if you see a fraction, let's clear that up first before you do anything else. Now that we've added that a over to the other side. So what's the opposite of divide by z? The opposite of divide by z is times by z. So I'm going to times this side by z, and I'm going to times this side by z. And notice I'm saying times the whole side. So if I'm timesing, or multiplying I should say, the entire side, I need to be sure and put parentheses, because I have to multiply each term by z. So I have to distribute that z. So that's going to make az plus ab. And it'll stay separate with the plus sign. Oh, I wrote plus ab. What am I saying? It should be plus bz, because it's just a times z and b times z. Sorry about that. Yeah, the a plus az plus bz won't combine. They'll just stay as az plus bz. They both have a z, but then they're still different because of the a and the b. Hope that makes sense. Now I'll just bring down the x plus y. Okay, and then this is needs to equal y. Right now it equals x plus y, so it's a positive x. So why not why don't we just minus the x out to the other side? And again, the x is not a like term with az or bz, so it just gets written on the end. It just gets tacked on there. Az plus bz minus x is equal to y. And that's the final answer. So in the fourth example, I'm giving you an actual formula. This is the area of a triangle formula. Area of a triangle is 1/2 times the base times the height. And then so it's written as 1/2 BH. So let me just rewrite it here for give us some room to work with. Okay, so looking at this, I need to get rid of two things in order to solve for the base. I need to get rid of this 1/2, and I need to get rid of the h. So I'll start by getting rid of the 1/2 first. In order to get rid of fractions, the best way is to flip it and multiply. Yes, you can divide by fractions. You could divide both sides by 1/2, but it would look like this. It would look like a divided by 1/2, and that just looks kind of confusing. So it's a lot less confusing to just remember to flip it and multiply. In other words, multiply by the reciprocal, and that'll cancel it. And so I'll cancel it there as well. And so 2/1, I can just write it as 2, right? It's a whole number. Anything over 1 is a whole number. So I have 2a, 2 times a is 2a, equals bh. And so bh, again, that's multiplying. So they're married together. And so I am going to divide them apart. So divide by h. And so I get base equal to, or base equals 2a over h. And that's it. That's the final answer. And yeah. This last example, I have area of a circle. That formula is a, or area, equals pi times r squared. R is the radius. So the radius is halfway across the middle of a circle. The diameter is all the way across. I know it's really easy to get those confused. So I could give you the area of a circle and I say, hey, what's the radius? Well, you would need to just do 2 quick steps. So I'm going to rewrite this, pi r squared. I'm going to try and write the pi somewhat neatly. Okay, so pi r squared means pi times r squared. So the first thing I can get rid of is just that pi. So the opposite of that would be divide. So if you divide the area by pi, you're left with r squared. That doesn't mean you're done, because a lot of times kids see the r and they're like, done. And then they even will just like erase the 2 and they're like, yeah, I'm done. But no, you still have that power of 2. Remember, that power of 2 is squaring. Squaring is multiplying by itself. So you are, think of it like this. 6 squared is 36. That's 6 times 6. How would I, if I wanted to know, what am I trying to say here? I'm trying to say the square root is the opposite of a square. That's what I'm trying to say. So if I said, hey, here's 36, what's the square root of 36? You just take the square root of 36 and you say it's 6. All right, so what's the square root of r squared? That's what I'm trying to say. The square root of r squared is just r. Because since it's r squared is r times r, square root that, boom, you're just left with r. I think I over-explained that one there. But, yeah. All you have to do is square root to get rid of a square. That's essentially what I'm trying to say. So r equals, and then make sure you put the a over pi in the radical. That's what it's called. The square root symbol is called a radical. Make sure you put it all together. And that's it. It's just those 2 steps. And you've now solved this circle for the radius, working backwards from the area. So hit that like and subscribe button if you want. Thank you for watching, and goodbye.